Hello everybody and welcome back to another visual pattern challenge. Here's our pattern today. Here's step 1, here's step 2, here's step 3, and your challenge is to predict the number of squares in step 4. If you can do that, can you predict the number in step 43? And can you write an equation that could be used to predict the number of squares in any step at all? That's the challenge. If you'd like to accept it, pause the video and see what you can do. All right, we've got kind of an odd little triangular arrangement of squares, and then there's 2 of them, and then there's 4 of them, and then looks like there's 8 of them. So this is growing really, really rapidly. Let's just start by creating a chart of the numbers and see what's going on. And then I'll ask if you think you know what kind of a pattern this is. So we'll make a chart with the step number and the number of squares. So in each of those triangles, 1, 2, 3, 4, 5, 6, there are 6. So I've got 2 times 6 in the first one. So that's 12 squares. And in the second one, it's 4 of those. So 4 times 6 is 24. And in the third one, it's 8 of those. So 6 times 8 is 48. And then my guess here, because we've got 2, 4, 8, we'd have 16 of these little triangles. So 16 times 6 would be 96. So that's my prediction for step 4. Do you agree with that? If you do agree with that, can you see what kind of a pattern this is? Do you think it's linear? Do you think it's quadratic? Do you think it's something else? So the way we usually approach this is to take the difference between each step and see what's happening. So 24 minus 12 is 12, 48 minus 24 is 24, and 96 minus 48 is 48. We don't get a constant, so it's not linear. And actually what we get is a repetition of our actual number of squares. So we had 12, 24, 48, etc. Here we got 12, 24, 48. If I do this again, I get 12, 24, it continues. So do you remember when this occurs in the numbers? This occurs in a type of pattern that's called exponential. So we have some number raised to the x power. So you'll see patterns like this when you have an exponential function. Exponential functions grow really, really rapidly, and that's exactly what this is doing here. You can notice that something's exponential when it's doubling or tripling or quadrupling every step. And that doubling, tripling, quadrupling, that is going to give you the base, the number that's raised to the x power. So the first question to ask when you suspect something is an exponential function is it doubling every turn? Is it tripling every turn? What's it doing between every step? And in this case, you can probably see pretty clearly it's doubling. 12 doubled is 24, 24 doubled is 48. So we're going to have 2 to the x power as our base. So we're pretty far along, although this can't be our total function because if we put in step 1 for x, 2 to the first power would be 2, but we have 12 here. So the first thing to try then is to think about a multiplier. What would I have to multiply 2 to the first power by to get to 12? And in this case, it would be 6. So that's a good bet. Let's try and see if this works. We know this works for step 1. 2 to the first power is 1. So that's, 2 to the first power is 2 times 6 is 12. How about in step 2? We'd say y equals 6 times 2 to the second. Well, 2 to the second is 4 times 6 is 24. Yeah, that's what we got in step 2. How about step 3? 6 times 2 to the third power. 2 to the third power is 8 times 6 is 48. Yeah, that's what we get in step 3. So this looks like it's working. So I think our equation is y equals 6 times 2 to the x power. Now we already predicted 96 for step 4. How about calculating the amount in step 43? You know it's going to be a pretty big number because anything to the 43rd power is going to be a pretty big number. And I would just use a calculator. So I think I'll just pop into Google Calculator here and let's see, 2x to the y 43, that's 8.796093 exponent 12. What does that mean? Well, that basically means 8 trillion and change. And then I multiply that by 6, and I get 5.277 to the 13th power, basically. So let me actually just take a quick snip here of what I got. And I'll paste it up in the window that you can see. So here's the thing I just did in the other window on the Google calculator. So that's 5.22 76558 e to the positive 13. That means 52 trillion and change. So that is a pretty big number. Well, how did that go for you? Did you see that this was an exponential pattern? That's a pretty tough thing to see in the beginning. Did you get 96 for step number 4? Did you come up with this kind of an equation? Not an easy thing to do. Let me know. Thanks, everybody.